Okay, let me just quickly repeat the fact and dimension. So in data warehouse or data mart, when you are storing the data in form of table, the table can be either a fact table or it can be a dimension table. This is the conventional way we are storing the data at our target database. Target means my source system is my OLTP transactional data that I mentioned last day, and the target means the data warehouse where we are storing our final tables where we are putting our meaningful data. The tables can be fact and dimension. Yeah, that I mentioned. What are facts? So fact means it can be quantifiable. How much, how many, those can be answered by fact. So those are facts, revenue, cost. And when we are putting all those facts, it's called fact table. Apart from facts, we are having those kind of foreign keys. Okay, I mentioned those topics yesterday as well. I'm just recapping this thing of fact and dimension. So the foreign key should be present. Those foreign keys are primary key of individual dimension. Suppose there are date dimension having date key as a primary key. There can be a store dimension having store key as a primary key. Product dimension should be there having product key as a primary key. And we are storing all the foreign keys in our fact table. Similar for billing table as well. Now, what are dimensions? If we just questions just like who, what, when, where, this kind of things, whatever answer we will be receiving from data set, that is dimension. So yeah, we are storing all the dimensions in dimension table. You can see in the store table, we are having all the store related information. In the product table, all the product related information. Having our primary keys as well, store key, product key. Okay. Now just concentrate one. You can see the primary key is here. And in fact, there is foreign key of store key. Why we are maintaining those foreign keys over there? So that we can make a join. You can set a data modeling. When we are segregating the stuffs in fact and dimension, that means we are doing a normalization. In the second day of our classes, we learned what is normalization process. So in data warehouse, when we are storing the data, we are following the same way over here. So the product table, the store table, this is totally normalized in process as well as the fact table. We are not maintaining all the columns in a single table. We are segregating the data in fact and dimensions. For each of the dimensions, we are creating the dimensions first. And to involve all those dimensions in fact, we are keeping a foreign keys which will be representing individual dimensions in the fact table. Okay. So I'll be just showing why those foreign keys are required during the data modeling creations and all. Okay, so here is some aspects on top of fact table. This is very important concept called grain and granularity in fact table. So what is grain? Grain is the business definition of a fact table's record. Let me just show you with an example. Okay, so here is a fact table. It's billing related information, so we are storing it over here. Okay, just give me some second. Okay, just okay. So billing related information, we are storing it over here. Only you can see those are fact information, quantity and amount. Apart from that, all the things are foreign key. Sales ID is not foreign key. Sales ID you can say over here it's a primary key in that fact table. Sales ID. Apart from that, everything is a foreign key. Store ID it can be the primary key of the store dimension table. Item code can be a foreign key in a product table. Date keys are foreign key which is present as a primary key in the date table, date dimension. Okay, but we are maintaining this foreign key over here as well just to define a proper grain and granularity. So what is the grain of this table? Now we are learning grain. Grain means representation of a single record. So we can tell, you can represent the particular record as sales transaction per store, per item, per date in a bill. So this is sales transaction. How many foreign keys we are going to involve over here? Just we need to add a per dimension, per dimension. This is the thing. If we are just going to include one more dimension, then just we need to include the definition as per dimension, per that particular dimensional key. Okay. So this is how fact can be defined. Suppose you are a developer, they can, the business, the architect can tell this should be our grain. Then you need to choose the DDL of the fact table. So you need to think what are the different columns can be there, and you need to create the fact table accordingly. Okay. This is how the grain is called in fact table. Now I'll be telling what is granularity, and I'll be showing how grains and granularity are totally interdependent. Okay. Let me go ahead with the second example as well. Okay. This is, you can see as per the thing, marks is the fact and the other things are dimensions. So you can say the grain as marks of a student received in a subject in a particular exam. So this is grain, means of what a particular record is signifying. Okay, a similar kind of stuff what we just learned. Now, what is granularity? Granularity means how much detailing level we are putting information in fact table. Okay, if we receive the data in fact table as much granular as the source system is having, in the source system we are getting very minute information. It's called atomic level data. The data is at the transactional level. It's called atomic level data. Okay, so we are putting very detailing level of data in fact table. And low granularity means this is very high granularity. And the low granularity means if we are summarizing the data, we are using some aggregation. We are not putting all the data related, at the transactional level. Rather, we are summing up this thing and putting the thing in the fact table. Then it's a low granularity data. Okay, let me go ahead with an example over here. Then I think it should be understandable. Let me open an Excel and uh, let me open this one. Not sure whether any. Okay, nothing is there. I'm just creating an example just to show you grain and granularity and how the things are interdependent. Suppose the student marks are fine. That table I'm just taking. Suppose year, particular class, subject, exam, marks. Okay, so marks is the fact table. Uh, okay, of course there should be a student ID. Student ID. Student name. Let me put student name. Anything I can do. So student name I'm putting Aryan. And then let me take the same student. Class 9. Subject. Let me put history. Exam maybe half yearly. Marks. Suppose he received uh, 85 in history in the same year. Class 9 history final exam he received 70. 2022 9 Suppose biology. Yearly 38. Hmm. Let me take two more rows, then I'll tell you. It was 72. Hmm. Okay, let me go ahead with this example. Okay, so what is the grain? Anyone? What is the grain of the stubble? Anyone? Anyone please tell? Try to just recall what is the grain of this fact table. Not sure whether it's
I
understandable.
think it's
Yeah,
Marx.
yeah, marks. Marks is the fact table. So how we can define the grain of this fact table? So while defining grain, we need to include all the dimensions as well. So that I mentioned. So the grain should be marks of a student in a particular year, in a particular class, in a particular subject, in an exam. So we are using per each of the dimension. All those things are dimension. Generally in the fact table, we should not put this way. You can put exam ID. You have to put one or two. Maybe there is another exam dimension where exam ID and exam name should be there. Over here, this should be the ideal way of storing fact, but I'm not putting all those foreign key over here. Rather, I'm directly putting the, dimension itself over here. But the best approach should be always this kind of thing. Suppose exam ID, and over here I am putting an exam table in this way. Exam ID versus exam name. There are two kind of exams over there only. First and two. Second, first should be half yearly and second should be annual. Okay, and I can replace one and two over here. This is the ideal way of representing fact table, but I'm not putting any foreign key. I'm just directly putting the dimensions over here, just for a quick understanding. So the grain I can tell, the grain of this fact table is called marks received by a student in a particular year, in a particular class, subject, in a particular subject, in a particular exam. So I'm just doing a per dimension, whatever, what is the fact information that is called grain. Okay. Now, granularity. Granularity means how much depth we are picking up the data. Suppose I am I'm changing some grain over here. Okay. I'm changing exam. I do not need exam. So I'm removing this thing. I'm hiding this thing. Okay. So there is a change in my grain. Currently, no exam is there. So I cannot put this kind of marks because you can see there duplication. So instead of putting this thing, I need to change my granularity immediately. I need to summarize this thing and this two row can be a single row. Okay, did you get it? Let me just put a quick note. So Aryan Dev 2022 9 history. There are two entries 85, 70. Earlier there was one particular dimension. That is why a granularity was higher. But one dimension has been removed. Now my granularity should be lower. I need to summarize these two and putting in a single record. I need to aggregate this function. The summation of 85 and 70 is 115. Let me just keep this thing in another data set, or sorry, let me put it over here in a new sheet. Okay. So exam is getting lost or hidden. Now we have duplication. Let me summarize this thing. That should be 1 1. Sorry, what was that? 155. So instead of putting two different rows, Aryan received total history marks 155 in the entire year of 2022. I can hide this row now. Okay. Now this is the original one. I mean, the summarized one. Similarly, for this one, biology, Aryan has two different biology, but I need to summarize this thing. 180 should be there. Hide. Okay. Now this thing is significant. You can compare, the fact is same. We are representing the same table. Just we change the grain. We change the grain. We just remove the exam dimension in the fact table. As soon as we change the grain, we can see the granularity is modified. Means we are not picking up data in the lowermost atomic level. Over here, we are aggregating 155. We are not picking up the record based on exam level. Okay. So here how granularity affects on top of grain. But you can see the total fact is same in both of the table. This is the difference of grain and granularity and how they are interdependent. Okay, 502. Over here it's 502. Similarly, we can remove one more thing. Suppose I'm removing subject as well. Hide. So we have removed one more dimensions. So our grain has been updated. We can tell marks for a particular student in a particular year. Okay. So I can change the marks as well. 335. I can hide it. 167. I can hide it. Okay. So this is the fact table now, but it's very, very low granular. I'm just directly putting the total marks that particular student received in 2022. Okay. If anyone questions, uh, what was the performance in their annual result, I cannot confirm from this table because I did not capture the data till that transactional level. Okay. So this is the difference between granularity, I mean, and grain, how we need to choose, but those are totally dependent on each other. Okay, so now based on the, I mean, the particular visualization or particular transactional level data, what is required in future or for the visualization purpose, what kind of transactional information they required. So based on that, we need to design the grain and granularity. Okay, so this is the way of make it happening. Suppose this one is there. I need to include another dimension. Till now, we are just removing the dimensions. I'm including one more dimensions. Suppose I need to analysis, have a good analysis more than that. So I need to have a good analysis on top of Aryan. What is the response? I mean, I mean, what analysis we can help him? So we can help what kind of questions he is more comfortable and what kind of questions he is not comfortable. So I'm just adding one more dimensions over here. So the dimensions can be question type. Okay, I'm segregating this row because we are introducing one more dimensions over here. That is why the data should be captured with more granularity level. So I need to increase my row number. Okay, I'm putting same thing over here. Just putting broad question over here, short question or MCQ. Okay, now I need to segregate and need to check in MCQ. Maybe he received 40 and in broad question he received 45. Just a second. Okay, so yeah, 45. So you can see we are digging more deeper. This is the data is more such, the granularity of the data is much more now. Okay. And we introduce a new dimension over here and the data is more granular now. This way we can add some more things. So the more granularity it is at the visualization level, the analysis should be much more good. We can, for the analysis purpose, we need to, work with Aryan, the particular question type. Maybe what is the result of this? How he can improve on the broad questions as well as short questions. What things are poor to him. So I can focus only on top of this. Okay. So this is how it should help. Yeah. Vishnu, tell me.
So Sautik, so the more the number of dimensions, could we say that the more the granularity?
Correct.
Okay.
Okay. This is understandable, I hope. Correct for everyone. Thanks, Vishnu, for asking question.
Thank you.
Yeah. So particularly actually the architect or the business need to confirm how much granular level we need to capture the data. So after that, from the developer side, we'll be designing the fact tables, DDL, what should be the columns, how we'll be capturing during the ETL design. We need to map those things as well. We'll be coming those things later.
And like I was absent for the last class, so
Okay.
is there any way that I can access the recording? And like, is this regarding Snowflake schema or Star schema, the one which you are explaining today?
This is simply fact only. So we learned
Oh,
how to put the data in. It's very basic actually. We didn't go
okay.
ahead with the schema part till. Schema means you are referring the data modeling, correct?
Yes.
Yeah, we haven't. Reached
Okay.
that point till now. So it's very basic how
Okay.
we are storing data in fact. Okay.
Okay. Okay. Fine.
Okay. Yeah, and the recording part, I provided these things to a particular team member from Tetra actually. So he used to put all the recording in some link so that you can see this. I hope I provided till yesterday's recording to him. So he might be put this thing. If you are not aware, just put the questions to have the updated YouTube link in the group. So maybe that person can help you with the updated
Yeah.
link
Yeah.
pasting in the group.
Sure.
This is for everyone.
Okay.
So whoever is required, just give me some time. Let me drink some water. Okay. So this is a aspect in fact table. Now we'll be moving something with the dimension. Okay. Yesterday I also told one important thing. So you can see in the fact table, the fact tables, the data volume should be huge because whatever we are doing the transactions, okay, that can be stored in fact table mainly. And the dimension table is very slowly. The particular volume of dimension table should be very less comparing to fact table. This is one thing, as well as the data insertion frequency is also very, very less than that of fact table. Because fact table is having all the transactional level information. The marks should be there. Maybe in a shopping mall, there should be billing related information. In each minute or in each 5 minutes, there should be a new billing inserted in the fact table. Okay. But in the dimension table, suppose product dimension. Product dimensions means all the product related. In product dimension, what should be the column? Maybe the product ID is the primary key. Maybe the product name, particular brand name. So that can be the columns in the product table. So I'm not going to launch or I'm not going to add a daily basis product in my shopping mall. Maybe after 2 months, there is a new product. So as soon as there is a new product, there should be a new record inserted in the product dimension. Maybe store dimension. In store dimensions, whatever store I am having, maybe there are 30 stores all over countries for my shopping mall. So that is why in the store dimension, there are 30 rows are there. I'm not going to introduce new store daily basis. Even in a particular year, I do not, I didn't open a new store. So that is why the store table or store dimension table should be having fixed record the entire year. So that is why dimensions are called very slowly changing in nature. Okay, and facts are very highly changing in nature. Okay, so for the dimensions, there are three patterns of data storing as well. We are mentioning it slowly changing dimensions. Yeah, dimensions are really slowly changing, but over here it's a representation of different dimensions with storing the historical information. So based on the historical information, we can tell it's ACD type 1, ACD type 2, ACD type 3. Okay, so what are the things? Let me open an Excel. I hope I have an access example on top of that. Not this one. Yeah, ACD examples are there. Yes. So I have an example over here ready. So ACD type 1. Let's focus on ACD type 1 first. ACD type 1 is the simplest one, the dimension where we are not maintaining any history. Okay, suppose we have an employee dimension where we are storing all of my employees information. Okay, so this employee information you can see uh, employee IDs are there. Those are employees name and their designation. I can put it over here. Trainee, account manager, developer, senior developer. Okay, this is maybe a particular days we received this data from the source system. That is why we kept this thing in our target system. Okay. After maybe 1 year or maybe some days, we checked what is the source system's data again. We found there is some modification. The employee ID 1, his designation has been updated from trainee to developer. Okay. Maybe his probational period has been completed. So he has been promoted to developer. As well as a new resource has joined. So that is why we took the employee as employee ID 5 and he has joined with the training. So this way we are storing the information, but there is no such historical information. Maybe what is the transition date, particularly in which date the particular employee has been designated from trainee to developer. Maybe my question arises, suppose employee ID 3, whether that particular employee joined as a freshers, as a trainee in that company, or he or she joined directly as a developer, switched from a different company and joined as a developer. This kind of question will not satisfy. From this table, it will not satisfy my question's answer. Okay. So to solve this, we need to introduce some historical column. So that is why we are moving to ACD type 2. In SCD type 1, we are just maintaining in this way. We are not storing any historical informations and all. So that is why we are moving to SCD type 2. Over there, we are just keeping a date to store historical information. You can see over here, particular date is there. Okay. In the second step, when we are receiving new information, we are storing the informations over here, just like this. Training 23rd Jan, and in the very next day, 24th Jan, we received as developer. Okay, so we have the transition date as well. Which particular date the particular employee's designation has been updated. We are not storing every day's data. Just suppose we are checking that the particular rows has been modified based on the employee ID. Okay, then we are storing the old information as well as the new information. Okay, so this way we can store the data, and this kind of data representation can help. I mean, this kind of questions, the transition related stuffs, or whether the particular employee is fresher, I mean, joins from the fresher in the company, or he or she switched from a different company and joined as an employee in this company. Okay, and what is type 3? Type 3, it's a bit, I mean, another, I mean, it's a different, we are different, I mean, definitely we are maintaining the history, but we are not increasing the row number over here. We are increasing the row number over here by storing the data. But over here, it's a bit different. We are introducing another column, just like employee designation, transition date, previous designation. I'm introducing a new column so that my row number should be fixed. If anything required, I can, have an entry in the new column in previous designation. Okay. So you can see just this one. This is the transition date. I'll be just maintaining the last transition date, previous designation. Okay. This way, if we just store this kind of data in this way, this is called SCD type 3. This is a, I mean, good example of understanding those uh, SCD type 1, type 2, type 3. But I mean, maybe the question may arises in the interviews. This is very important topic. What is SCD? Type 1, type 2, type 3? They can ask you questions, and they can tell you how to implement in this thing. I mean, this kind of things in the data warehouses and all. So you can just have a go through in the same topic in a web as well. Any doubts so far while learning SCD? Anything? Any issue? It's clear for everyone? Irfan, Mustafa, Tarun, Ajitha. Actually, I didn't. Okay. Anyone is new in, I mean, in today's session? Anyone joined as a new member over here?
Oh, yeah, I'm a new guy.
Okay, hi Naresh.
Nice. Hi, hi, hi.
So, do
So
you
I'm
already
sorry to
have the
say
experience in data engineering, or?
no. I don't have any experience. I'm a fresher candidate. So I just want to miss the previous class. So what's the difference between the like your type 2 and like type 3? Man or the?
Okay, it's a different kind of representation. In type 2 over here, we can see the daily basis the data is coming. When we are seeing this kind of matches, we are inserting a new records over here. So over here, the record counts will be increased to maintain the historical information. So here, it's another kind of representation. We're increasing a column over here just to store previous designation. So when we are receiving this kind of records from the source side, we are not storing as a different record. Rather, we are keeping this thing in a single record and putting this is the current designation and this is the previous designation. This is a kind of storing of the different kind, I mean, dimensions over here.
Okay, and the SCD type 2, we have like in the second column, we have the duplicate data, right? The duplicate one, the 1 and 1. So that may be the
Duplicate based on
variance.
employee IDs, correct. But
Yeah, but
if
we
you
can
can see
consider
the
as
all
an
the
S.
data, it's not duplicate. The employee designation is different.
Okay, I
Okay.
got it. Okay, thank you.
Employee ID duplicate, employee name is duplicate, but there is different employee designation. That is why a new record has been inserted. So Naresh, as you were quite new for data, so just to mention, we have started the classes on 20th,
Yeah,
20th December actually. So you can get if there is any friend of, I mean, in data, then you can directly hold of him and get the topics, or you can check the previous recordings. We completed the SQL classes and we just started. Yeah, do you know SQL already or?
yeah. I was like, I was going through some like YouTube videos. I'm just learning from over there, and I was
Okay,
just
okay,
like started my like in this consultancy. I was started like 2 days back.
okay,
So
okay,
I'm going through by myself in the like in the SQL and all the things which I
okay,
didn't know
great,
that,
great.
like I was going
Yeah.
through by myself.
Okay, fine. If this is helpful, that it's fine. And if there is
Yeah,
any
okay,
step
thank
point,
you.
you can discuss in the class, no issue. But
Yeah,
if you, I mean, want more I mean, more help on top of that, then you need to wait for the next class to be started. Again, it should be repeated in the next class. This is for everyone who is joining as a new resource. Please try to go through the recordings. I hope that should be helpful. If you already have some experiences, that should be helpful. But if you still find it's a stuck point, and then you have to wait for the next class again. We will be starting the next class maybe after 2 or 3 weeks when our Python should be ended. Then again, the same thing will be repeated. Okay. Okay, Naresh. And I also provided a one
how
exercise to
small?
everyone.
How a small
So,
question can I ask you, if you
yeah,
don't
Naresh,
mind?
please. Great.
Like I know the like we like the data engineer has like everyone has using the same tool, right? When we extracting data, like anything. So may I know the like can I get your personal number so I can go through there and I can text you like I can need some help from you. So what are the topics we're gonna cover in this, and what are the tools we're gonna cover in the, I don't know, like the first class, what you thought for the guys, I don't know, but I want to learn from you like the what are the things you thought for for these guys, and I want to learn from that, and the like the key points of the any like the things like Power BI or Tableau or whatever it may be.
Yeah,
So
yeah, yeah, definitely.
it's my
Maybe after,
personal suggestion. I'm just requesting you to the like just knowing the things.
yeah, yeah. Let's complete the class for today's.
Yeah,
And
okay,
maybe
sure.
we can stay for 5 more minutes. We can discuss these topics.
Yeah, okay,
Okay,
sure,
what
definitely.
I'll be
Thank you.
showing the syllabus quickly and what are the things we'll be going to cover in these sessions and all. So these things we'll be discussing as well as if anybody can help you, I can just check. Okay. Okay, let's quickly complete this class. We'll be connecting after 10-15 minutes. Okay, so this is how the SCD, different kind of SCDs representation can be seen. So I'm moving to the next topic. Yeah, now it's data modeling. When our dimensions and facts are ready. Okay, let me just maximize the screen. It's data modeling or ER modeling. It's, I mean, there is a different name as well. So data modeling is we are doing nothing but we are combining the fact and dimensions. So as I mentioned, we should be having fact. You can see this is the fact table, and those are our different dimension table. This is product dimension, customer dimension, register dimension, and how those things time dimension, store dimension, clerk dimension, promo dimension, and for each of the dimension, you can see one particular key they are contributing to the fact table. So there should be what number of dimensions there are. So you can see there is a contribution of their individual dimensions as a representation of a particular column over here in fact table. So what we just discussed, it's called this thing, and this entire picture is called data modeling. Just to check the relation between a fact and dimensions and the common column means the primary key from the dimensions and the foreign key in the fact table. Suppose I just need to check, I need to include those department category with my facts information. Then I need to join these two table based on product key. So in the join exercise, we learned how to join and all. So I need to join two tables, the product dimensions and fact dimensions to create the OLAP. I told you what is OLAP, especially for the reporting guys. Means with the visualization team who are working in Tableau, ClickSense and all. So they need those two tables. They will be joining these two tables, maybe product based on product key, and they'll be pulling those informations along with dollar cost, unit sold and all. So this is the way, or this is the, useful of data modeling. If we can check the data modeling quickly, then we can have the understanding what is the relationship between each fact and dimension. Okay. The data model can be divided into two things. Particular two ways we can segregate the data modeling. One is called star schema and another one is called snowflake schema. Okay. This is very, very important topic. In interviewer must ask the questions. You can get the questions. What is the difference between star schema and snowflake schema? For the star schema, there should be a single fact table to be joined with multiple dimensions tables. It's the same example that I showed to you. It's a star schema. Okay. And okay, this is a quick example of star schema. There should be a single fact table over here, and the surroundings you can see there are lots of dimensions. Okay, it looks like a star. That is why it's called star schema. Star schema of data modeling. Okay, it's also called schema. We learned what is database schemas. It's a bit different over here. In the data modeling, there is also schema convention. This is called star schema. Okay. Now, what is snowflake schema? In the snowflake schema, there can be some of the dimensions which are not directly contributing their primary keys into fact. Rather, we can say a particular dimensions are normalized further in another dimension. This is one particular example. Just like category. Category is a dimension. Category, it's not directly giving its primary key in the fact. So there is no contributions of the grain from the category. Okay. Suppose there is no such direct relationship with the category ID with any of the fact data. But I need to include this thing as a dimension. If this is the scenario, we can create the snowflake schema. It's not star because there is no such direct relationship with category ID and facts, brand ID and any of the facts. Okay, we have direct relationship between brand and product, category and brand. That is why we are keeping in this way. This kind of data modeling is called snowflake data modeling. So based on actually in our live project and all, we need to determine which kind of snowflake, which kind of schema convention we need to follow based on the data as well as what is the current scenarios and all. If there is any such dimensions which do not have any relationship with the facts and all, based on that, we need to determine which particular schema we need to go ahead. Okay. Please go through this topic once more time. Just like SCD, I told this is very important thing. Check SCD type 1, type 2, type 3 from the web to get more insights. Similarly, check the difference between star schema and snowflake schema. This question is very, very important, and interviewers might ask this question to you. This is the basic difference just I told. Maybe they can ask which reason, which scenario you need to use this thing and all. So just get prepared for this thing. If you face any difficulties, please tell me in the next class. Okay, now I'm moving to the ETL. So ETL topic we covered in last day. What is ETL? ETL is a kind of tool which will store the data from our source system to the target data warehouse. Okay, in data warehouse, we just have the knowledge. We need to create fact and dimension so that we can create the data modeling. Okay, the data modeling is required especially for the visualization team. Maybe we are from data ETL team. We stored the data in data warehouse in fact and dimension. Now the visualization team, they require the data modeling. Based on the data modeling, they will be doing, they will be doing the OLAP analysis. They can combine all the columns from fact and dimensions and create a huge intermediate table. On top of this table, they will be creating the charts and graphs. This is the entire data flow. Okay, and that is why the data modeling is required. They need to know the cardinality or the joining condition between the fact and dimension. Now again, I'm coming back to the data team again. Data team means they will be flowing the data from source to target by help with some tools or maybe with some languages. But those are called ETL. ETL means I already explained. ETL means extracting from the source system, extracting data from the source system, transforming the data as per the business requirements, and then store the data at the target site. Maybe the data warehouse can be the target. Well, when they'll be storing the data, they need to maintain fact and load. Fact and dimension format. Okay. So this is the purpose of the ETL. ETL is the medium to do this kind of thing. Now, ETL, the main important thing, extracting and loading, there are several strategies. Transformation is, how we can clean the data. Maybe there are very unclean data are there. So we need to check and clean those data. We need to transform it. Maybe some summarization is required to make it a low granular level. So I need to summarize these things. I need to put lots of functions. Maybe just like we checked the first name and last name. We need to concatenate those things. So we can have concatenations of strings and all to get the full name. So this kind of small uh, transformation we can do. Suppose we have billing information in a particular currency. It's not local currency, we are following the USD over there. But maybe for business purpose, some of the users require some local currencies transformations as well. So in the transformation, we need to introduce a new column to have the local currency values. So this kind of transformation we need to make. As of now, I'll be just mentioning some of the loading and extracting strategy over here. Okay. So what are the different extracting strategy? Extracting means data extraction from the source system, from the OLTP system. So either the load strategy can be a full refresh or it can be a incremental data refresh. Just give me some second. Okay, sorry for that. Just give me some second. Okay, so data extracting method. So what is full refresh? Full refresh means, suppose in OLTP means our source system database, we have a particular table. The table is having, suppose 1,000 records are there. Okay, in today's date. So today ETL job will run and it will load the target table with 1,000 records. Maybe tomorrow we received 100 more records. So tomorrow, what should be my source table's volume? Data volume should be 1000 and 100. Now, in the target table, while loading the target table, I have two approach. The first approach should be full refresh, means I can truncate my target table, okay, and extract all the information, the full information from the source system's data. The total 1000 and 100 records will be pushed to my target at a single go. This is called full refresh. Means daily basis, I'll be truncating my target table and pulling all the records from the source table and pushing it to the target table. My source and target will be in sync, but I'll be doing a full refresh. Okay. Suppose I'm loading a fact table. It's having millions of records. Today, suppose there are 5 million records. Tomorrow, 1 million extra records should be inserted. 6 million. If we have larger number of records, the ETL process will be a bit slower. As for the throughput of the ETL, I mean, there are some limitation. Maybe a particular ETL tool is having some throughputs. It can process maybe 1000 records per minute or 1000 records per second. If this is the scenario, to store or to process 5 million records, maybe they will take lots of time. Okay. So this kind of performance issue should be there if we just load daily basis a full refresh. So there is a concept called incremental data load. We will not be loading full refresh daily basis because yesterday's 1000 records are already there at my target. So why I'll be loading again those 1000 records? So incremental data load, it will be helping me with only the incremental data. So our ETL system will check what are the new records came into the source system. Okay, it will check for the new records for the source system. It will compare till what data we have loaded in the last working day and what are the new records come into the picture in the source system. It will only took those new records and it will be pushing to the target. So this is called incremental data load. Full means it will be taking all the records from the source system and pushing it to target. Incremental means it will take only the delta record, means what are the new records received at the source system. It will be pushing the same thing at the target. Similarly, it's quite related, the extracting and loading strategy. Just I mentioned truncate load is required for the full refresh. When we are extracting for the full refresh at the target side, we need to do truncate load. When we will be going into the incremental extracting from the source system, either we need to go ahead with insertion method or it can be update insert. Why we require these two? Because maybe in incremental data load, we find such record. Suppose one particular employee's designation has been updated. Okay. So how we can check the incremental data load? We can check based on the primary key. A primary key's other columns attribute has been modified. So just like the previous example, a trainee has been updated to developer. Okay. So that particular developer, the particular record has been updated. We cannot tell a new record has been inserted for this case. A particular record has been updated. So that is why if we want to capture the update one in update thing and the new records as the insert thing, so we need to follow update and insert. Means if any record come as a update at the source system, we need to only update at the target side. If we received a brand new record at the source system, that should be inserted at the target. So this is called update and insert loading strategy. In short form, we can also tell this upsert. Okay, upsert loading strategy. And if the design strategy is such a way that all the records, whatever new records we are receiving, we just need to insert it, whether it's updated or not. We do not have to think about it. We just need to insert the delta extraction data. Then we just need to go ahead with insertion only, the second one. It's also called append data load. Insert or append, anything is applicable. So this is another loading strategy. Okay, we already covered up the time. So tomorrow I'll be just giving you
Excuse me.
a quick example on top of this. Maybe in Excel. On top of Excel, I'll be showing this thing. What is different loading strategies and all, so that you can memorize these things. Okay, anyone is telling something?
You came the previous one, the full refreshment. You told right just now. So there is any limit for that? The previous one, yeah, the full refresh, yeah. There is any
No,
limit of
there
the
is no
data
such
reaching of
limit.
the source to destination? There's no limit for that.
No limit is there. Based on the database tools, their performance. If there is any limit at the database tool, maybe your DBA set up some limit at the database. Maybe your database doesn't have any memory further to store the data. Then there can be limit. But in generally, there is no such limit for full refresh. Okay. Based on each of the project, maybe the database team, there are some timeout. They are not loading. Maybe after loading millions of records, 1 million record, it's getting timed out. So you are getting some failure. So it's
So
based
why
on
don't
project. The DBA can set up something, but generally there is no such rule. For full refresh, we can go ahead with this many records and all. There is no such rules.
okay? So there is no for the source to destination. There is no we can store particular we can store, even though we can store here the incremental. Because you told me the last time the example 5 million and the 6 million. You told me example one, right?
Mhm,
So we
mhm.
can store the in the full refreshment like that, or no? Like we can store in that way millions the data, we can store in number of data, or there is only the particular limit in the task when we are storing the data.
Yeah, generally, both are there. Extracting method. We can go
Yeah.
ahead with both of them, but generally, what we should do, if the record count is very high and the record refreshing frequency from the source side is very high, then we need to choose incremental data load just to avoid performance issue.
Yeah. Okay. Sure.
Okay.
Thank you. I got it.
And if the data is less, especially for the dimensions, we can also go ahead with incremental data load for all the tables. But to implement the incremental logic, it's a bit difficult for the ETL developer. So suppose we have only 100 of records, okay, and we are not maintaining SCD type 2. We are just maintaining SCD type 1 for particular dimension. Then we have 100 of records. Why we need to design so much things just like incremental data load in my strategy? Let's go ahead with the full refresh. So this can be the motto of some of the developers. We have hundreds of records. It should hardly take 2 to 3 minutes for a full refresh for a particular dimension. Then we can go ahead with the full refresh. Full refresh design strategy is very simple for the developer purpose. So that is why, based on the developer's choice as well as maybe their leads or manager's choice, we can go ahead with the data loading strategy or extracting strategy. Okay. Tomorrow we'll be explaining with maybe with the Excel sheet. I'll be keeping some records and I'll be explaining this thing again so that the thing should be clearer to you. And tomorrow we'll be also covering the rest of the part of the slides. Okay. So let's close the topic for today. And okay, now Naresh, you are telling something. You can just ask the question. The other, persons, you can feel free to drop or you can stay as for you wish.